All right. Many of you might be familiar with this term, the Great Acceleration. And the Great Acceleration is something fascinating. It's a double-edged sword. On the first hand, it's a summary of the global trends in the world that have contributed to human welfare, not to all, but to many people. On the other hand, it also shows the way we're undermining the capacity of our biosphere. And when I talk about the biosphere, I mean the sum and function of all the world's ecosystems and the role they play for human welfare. So the Great Accelerations has put us in a state where we can enjoy good lives, many of us, not all, but also creates new risks. And one of the things that we're discovering, and that's the wrong direction, there you go, is that actually there's no place on the planet today, I would argue, that has not been modified by human activities all over the world. And the thing that is interesting but also a bit challenging is the fact that it's not only about us influencing the planet, but it's also how this undermines what we call Earth system resilience. And just to go through this slide, I think I might have a pointer, but I'm not gonna try that out. This is just a simple graph. It's a proxy for CO2 levels in the world over time, going back 100,000 years. And you see that blue line moving around up and down over time, which is an indication of the lack of climate stability. Essentially, climate changed a lot during those periods, up till a certain time. That was 10,000 years ago, when you see that red circle called the Holocene. Is an unusual, stable time in the history of planet Earth in climate that allows human civilization to flourish. I think we need to keep that in mind, that looking through what we call deep time, the history of planet Earth, we have experienced an unusual, stable climate that has allowed human societies to prosper, that has allowed human civilization to grow. So we should be very happy that Earth resilience exists in this sense. The question is, how does this affect what we do today, right? I mean, we're facing difficult challenges today, and you're going back to your offices next week, and you have to take hard decisions. And I think there are two key issues that I normally share with my political science colleagues. It's both about time, this long-term perspective, but also responsibility. And just to give you an example of why that matters, so this is a really interesting, very technical paper from Nature Climate Change on the consequences of climate change and sea level change. It's a bit technical, it goes back hundreds of thousands of years, but then there's a key sentence in the abstract and in the article that I think is super interesting. And it says something like this: this long-term perspective illustrates that policy decisions made in the next few years to decades will have profound impacts on global climate, ecosystems, and human societies, not just for this century, but for the next 10 millennia and beyond. Which is sort of a paradox, right? So thinking about this long time where stability, you just find this sort of stability that allows human civilization to prosper for the last 10,000 years. The window for keeping that stability, maintaining that stability into the future is short. Do you understand the paradox? So I mean, the actions that we take within the next decennia are going, or decades, are going to define what the Earth system looks like for the next thousands of years. And normally, I mean, in my studies, when I look at institutions and policies, we would probably focus on the next decade or the next 5 years, or what happened 20 years ago or 10 years ago. This new perspective on time I find fascinating. So again, that's from the same article. You see that the black dot is where we are today, and the different blue lines depends on what trajectory we move into, whether we move into a 2-degree world or a 5-degree world. And the point is that you're here, and the decisions that are made here in the next decades will define where we find ourselves in the next 100,000 years on that blue line. So it's about time, and it's about responsibility. The question is, of course, the global goals. How does this link to the global goals? This is a very tangible thing. Everyone is talking about it. And I love the global goals. I think the SDGs are a fascinating and a good tool to move the global community ahead. But I have one issue, and my colleagues have one issue with the global goals. It's the fact that it doesn't acknowledge this. So this is a remodification that we made on the global goals, putting the biosphere as the basis for economic development and social development. And I think it sort of brings, again, the fact that the climate stability we see in the Holocene is unusually stable. If we want to maintain human prosperity, economic development, and tackle poverty, we need to make sure that the basis for those activities remains stable. So the biosphere, land, water, climate, etc. Some of you might be provoked by this, but looking at this from an Earth system perspective, this makes a whole lot of sense. One of the things that we also struggle with in terms of thinking about resilience and thinking about environmental change is the fact that the planet is connected. Many of you have probably seen this picture, planetary boundaries. You heard about planetary boundaries? No? Some of you yes, some of you no. Just a very quick summary. So planetary boundaries is a framework that my boss, Johan Rockström, and colleagues developed in 2009 and published in Nature that argued that there are a number of processes at the level of the planet that define the stability of the planet to maintain human well-being at a longer term. One of them is climate. Of course, we all know about climate. But then there are actually 8 other ones. So there are 8 different processes at the global level that allow the Earth system to maintain at a stable state. So it's biodiversity loss, it's land use change, it's the use of fresh water, ocean acidification, and other boundaries. And the ones that you see in red, we've already transgressed what should be seen as safe. This is a very powerful framework because it brings together a lot of different sciences. And it's also powerful in the sense that it has had some impact on policy. It's quite easy to communicate to policymakers. The problem is that there's a tendency to take this and then think about slicing planetary boundaries up and then distribute globally across people, right? So if the biodiversity boundary is X and there are X billion people on the planet, then you can reduce biodiversity with so much, right? Which I think is a bit problematic, even though it's an interesting thought experiment. And one of the main problems is that actually many of these boundaries are connected, right? So you can't address climate change unless you address land use change at the same time. You can't operate within a safe space for global freshwater use without considering land use change, for example. You can't deal with marine biodiversity issues if you don't acknowledge the role of ocean acidification. That's linked to climate change. So these are all interlinked issues, which creates challenges for governance. This is just from the social domain. So the first ones that I mentioned were just biogeophysical. This is from Dirk Helming's paper in Nature. And that graphics have been used by the World Economic Forum, essentially looking at how are global risks connected to each other, right? So financial failure is linked to things as global governance failure, etc. So things are connected. And another challenge is that these global risks are dynamic, so they change over time. And the reason for that is thanks to us, because we modify the planet, we globalize our economies, etc. So just to give you an example of how we are modifying or maybe creating new risks. So this is a slide from 2002, 2004 on the amount of land investments from one country to another, right? So the size or thickness of the arrow is 1,000 hectares. So you can see, for example, the green lines go to the US, investments in Africa, South America, for example. So that's in 2002, 2004. And then we see a slight change in 2005 and 2008. So this is just before the food crisis, for those who remember that. And then 2009, 2012. So that's foreign land investments. So we're doing things. on the planet. We're linking systems, we're linking regions, we're linking changes to different parts of the world. So we're in a highly, highly connected planet, and we continue to connect it, and by doing that, we're connecting risks in new ways. And that creates the call for resilience, right? That's why we need resilience. If you're dealing with systems that are not fully predictable, where change is constant, you need a capacity to deal with the unexpected. You need to be able to address unavoidable uncertainty. It doesn't matter how much data you have, it doesn't matter how good models you have, it doesn't matter how many foresight workshops you organize, there will always be uncertainty, and you need to find strategies to deal with that. And that's why resilience is critical. The question is, of course, what is resilience? What do people mean when they talk about resilience? And I will just give you how we look at resilience from a research perspective at the Stockholm Resilience Centre, which sometimes doesn't really match what other people think about resilience, but this is our take on it. First of it, resilience has 3 components. One is persistence. So it's the capacity to withstand shocks. So you face a shock and then you bounce back. One component. The second component is adaptability, the capacity to promote collective action and adapt to changes, maybe with some foresight, right? So, like if you think about climate adaptation, that's adaptability. But then there's the third component that's also part, as we see it, of resilience thinking, and that's transformability, the capacity of actors in a system to innovate and to change fundamentally when the stresses become too big or changes become too overwhelming in a system. You know that adaptation is not going to be enough, you need to transform. Fundamental, deep system change in institutions, mental models, policies, etc. So that's what I mean when I talk about resilience, all these 3 components. I'm going to skip that. Essentially the same thing. So I think this is I believe this to be a window for us in terms of how we look at the European arena, what the European arena should do in terms of thinking about Agenda 2030 and what global sustainability means. And think about this a bit, how it has developed in the world over time. In the 1950s, what we wanted was development for wealth, right? We wanted economic growth. In the 90s, around the Brundtland Commission, etc., we were talking about sustainable development. So it was growth, but at the same time minimizing environmental impacts. That's something that you're all familiar with. As stresses increase over time, we start to talk about these global trends, demographic trends, and how we can maintain sustainable development on a growing planet. And I think the agenda and the time has come to think about what resilience for development means in a turbulent world. Capacity to bounce back from shocks, to innovate and transform in the face of change and uncertainties. To me, this is a slightly different touch of how we should talk about global sustainability challenge. So how do you build resilience? What does it mean? How do you do it practically? I mean, one of my colleagues, Unse Biggs, put together a book volume for Cambridge University Press 2 years ago. It's kind of sort of a thick book, and they developed 7 principles for building resilience. I'm just going to go through them very quickly here. So one principle, things that we discover in studies, modeling, empirical analysis, comparisons across cases, etc. One is to maintain diversity and redundancy. Systems that have diversity and that are redundant, you see that there are a number of actors doing the same thing or this overlapping functions, are more resilient. They are able to cope with shocks and stresses and bounce back much faster. And they're also more innovative. Second principle, manage connectivity. It's great to have local sustainability, for example, in your community or in a city, but these cities are connected to other things. So you need to be able to manage that connectivity, just to give you an example. Manage slow variables and feedbacks. Be aware of changes that are pushing you towards a direction and things that might push you quicker through tipping points. foster complex adaptive systems thinking, essentially moving away from thinking that the world is predictable, linear, that you can plan for everything and consider that things are constantly moving and adaptive. Encourage learning, broaden participation, and promote polycentric governance systems, essentially systems that are linked across levels and that have overlapping functions. You can find all the details in that book. Some of them are going to be theoretical explorations and a lot of examples. But my idea is to give you something a little bit more hands-on to take home instead of just the principles, something that would be able to help us build this new European agenda for global sustainability. So just 4 points that I think are critical, which are sort of a way to operationalize resilience in this context. First of all, and based on the studies we've done on governance, there's a need to move from institutional fragmentation to innovation. And you all know, I mean, everyone that has worked with policymaking or in governance know that whenever you're dealing with an issue, you find fragmentation, you find silo thinking, you find issues falling between chairs, etc., and it becomes a problem. I'm just going to give you an example from my own research. We tried to do a global mapping of actors and rules, addressing the interplay between 3 planetary boundaries: climate change, ocean acidification, and marine biodiversity. These are not separate problems. These are closely interlinked. Climate change contributes to ocean acidification. Ocean acidification reduces marine biodiversity. And as the oceans become more acid and you lose marine biodiversity, oceans also lose the capacity to be a sink for CO2, which contributes to climate change. So you see these feedbacks. These are connected problems. The challenge is, of course, who's dealing with this connected problem? And you start mapping, and immediately you run into something like this. Extremely common in whatever problem you're looking at. And you see also, and this is just a selection, what we a bit ironically call an alphabet soup of different organizations responding to different parts of the problem in more or less coordinated ways. When you have a setting like this, and think again about the global scale, the limited time, the need to act, what you have is that you have, first of all, complex interaction between drivers in sense problems. You can also end up in settings where you have blame games between different organizations. So organization A, when something wrongs happen, organization A starts to blame organization B, and organization B blames organization C, which is a perfect setting for not learning from mistakes and not reforming things that you've done wrong. The institutional architecture is messy, and at the same time, it's difficult to just create one institutional solution to coordinate everything. Right? I mean, there's just not one way, one simple blueprint solution to solve this. So how do you work with this? Right? And that's one of the things that we see in our studies and we find intriguing is the fact that these actors are not naive, they're not stupid, they actually start to build collaborative networks. Probably like the network you're in here, right? Networks of actors that share information, that coordinate, and sometimes also are able to resolve conflicts. And if in some successful, very successful cases, actually actors in these networks, even these global, big, large actors, are able to use diversity as an opportunity for experimentation. They test new solutions, they pass around information from global to local, and they're able to adapt to changing circumstances. Right? So they're able to coordinate and modify their actions depending on what happens in the context, social, environmental, or ecological. That's something that we call adaptive governance. So that would be what I believe a key challenge for any advisor to any government at whatever scale to think about how to tackle fragmentation and use diversity and redundancy as a strength, as a possibility for innovation and experimentation. And I should be totally honest that, I mean, this is at the moment, this is a scientific agenda. We don't know a lot about these processes. We know they're happening, and we're trying to assess them, and there are different literatures from law and political science. So this is partly a scientific agenda that we're advancing, but this is, in a sense, also a policy agenda for everyone involved in decision-making, real-world decision-making, to use networks that exist, to do experiments, and to evaluate what's happening, and to be flexible to changes. So this is where science and policy can sort of come together and explore this more critically and do something tangible. All right, a second point, or a second way to operationalize what I just said about resilience and the biosphere to this agenda is the need to move from a framing around eco-efficiency to bio-positive innovation. And so if you think about the role of business models and the way we're pursuing innovation at the moment, so for example, carbon neutral products are great. That blue picture, if you think about smart grids, you probably heard about smart grids. I just read a quite interesting article about how the city of tomorrow can use artificial intelligence for transportation or whatever. It's extremely neat. It sounds good, but I don't think it's going to be enough. That's not the things that we need to get in place. If you want to stay, again, in that stable state of the Holocene, where you have climate stability, we need a Moore's law for biosphere innovation. It's not just about reducing environmental pressures, but actually adding environmental values to contribute to the stability of the planet, rather than just reducing pressures. It's a different twist. And I'm just going to give you a few examples of what those innovations could look like. And these are very small businesses, but they could have a potential. So these are two girls in Stockholm. They started a company called Be Urban. And essentially what they're selling are pollination services. So they're selling beehives to companies that they can put on their rooftops or in the gardens or whatever. So they're trying to replace losses of pollination services through a small business model, essentially selling ecosystem services. Quite neat. A second one, it's algae farming. Of course, you probably heard about it. It can reduce eutrophication. It's highly energy efficient, and it creates additional environmental values. A third one that our colleagues are working very developing at the moment, what they call social ecological urbanism. So essentially what they do is that they bring ecologists and architects together and then think about how would you build a new part of a city, not to reduce carbon footprint, not to reduce energy efficiency only, but actually once that area is in place, it has created new ecosystem services, it has increased biodiversity, it has increased water purification flows, etc. It's about creating more, not just about efficiency. And then the last company called Uniforms for the Dedicated, highly fashionable group of people in Stockholm who will love their clothes. They're working on something that they call smart textiles. And the idea is to use methane gas to create fabric. Right? So you would remove methane from air or from industrial activities and build it into fabrics. Right? Which I find genius. If you can do that at large scales, that would be fantastic. So what's the point? Well, what's the key thing with these innovations? These are just small businesses. Some of them are at the experimental level. But I think, why are they interesting? Why is this more interesting than, for example, artificial intelligence and smart grids? One thing, it builds on insights, deep insights into ecology. They know, I mean, if you want to sell pollination services, you need to know how ecology works. Right? So I think, and it's not a coincidence that actually many of these people are connected to our networks, and some of them are actually old students of ours. The second thing is that it's not about reducing environmental pressure or being efficient, it's about adding ecological services as your product is developed. And when you do that, you're actually increasing what we call a safe operating space. on the planet if you do that on large scales. You're expanding the possibilities of staying within that safe operating space. So normally we would think about cities, for example, in this one. I think the Keynote Habitat 3 conference is ongoing, and I think this is going to be one of the major topics. It should say urban opportunities. I don't know, something got lost there. So more than 60% of the areas projected to be urban in 2030 have yet to be built, which is an amazing opportunity if you do that correctly. Like it's such an opportunity to think about it. And thinking about this sort of innovation that I just talked about, you can think about this as an entrepreneurial opportunity as well. And there's questions mark, but if you think about the business models for tomorrow, I don't know how many percentages of them have yet to be created. They have not been created yet, which is a huge, huge opportunity if you focus on the positive sort of innovation that I've been talking about. It would be fantastic if we could have, the next Uber could be something that's biopositive. The third thing, and this is a very important point and something that we consistently talk to decision makers about when they talk about resilience, is that resilience is about not only coping with stresses or adapting, it's also about thinking cleverly about transformations and supporting transformation when that is needed. So again, I think this is a slide from a Canadian site that lists up different mitigation and adaptation options. For example, sustainable transportation, renewable energy, vehicle fuel efficiency would be mitigation, and then adaptation policies in health programs, emergency planning, helping vulnerable people, etc. It all makes sense. These are things that we need to do. But what happens in a setting where the intensity of shocks that you're projecting are so big and that the changes around a system, where is this a city or a country or a region, are so large that adaptation is not going to be enough. You need to do something completely different. How would you go about to do that? And again, I should be very clear. This is a scientific agenda at the moment. We have very intense discussions about this. For example, what's the difference between radical adaptation and transformation? How do you know that you've managed to transform your system? Do you know that after 5 years, or would it take you 20 years, etc.? So this is an ongoing research agenda. But there are a few things that we can say based on the literature, and the literature here being studies of large shifts in technological systems and the spread of social innovation, for example, is that transformations, and by that I mean large system changes in the way people think about something or the way institutions are organized, very often emerge in settings outside conventional decision-making structures. This might be provocative, especially if you're in a conventional decision-making structure yourselves, but if you think about it, new ideas, things that can transform, often take place outside, and often actually take place in a combination between someone or a few people or a group embedded in conventional decision-making, like an advisory board or a government office, and people outside. And what they do is that they create what people call a shadow network, or they form a niche, or they create something called a transition arena. These are different terms for essentially the same things. New ideas, combining with people outside formal conventional decision-making structures that shape the idea and maybe even initially test it at a small scale somewhere with some seed funding or whatever. That we know, we can map that. Once that idea looks good and seems like it could be upscaled, it is possible, at least that's what my Dutch colleagues tell me, to make that have a bigger impact through policies, through support, legislative changes, etc. And you can do that by, first of all, evaluating, and then you repeat that pilot in other parts, and then you can do three different things. You can upscale, so take it up, and by that having a larger impact. You can side scale, So essentially taking one solution or one pilot and move it to other parts. It could even be other countries. And you can deep scale. And deep scale means that you will go into an organization that has tried something but hasn't done it properly all the way, right? So that's deep scaling. Upscaling, side scaling, and deep scaling. And you can actually design processes to do that if you're brave enough. Because we also know, and we've also seen in the studies, that these sort of transformations, transformative changes, upscaling these pilot ideas that have large impacts require institutional entrepreneurs. It requires one or a couple of brave, energetic individuals to push the idea all the way. So individuals matter. Individuals, policies, and shadow networks. That's the combination. What we find interesting, though, in our work is that these sort of large-scale ideas could also actually be supported from the top. So I'm just going to share one process that we're involved in, which is a science policy. It started out as a scientific project, but has now moved into the domain of trying to influence real-world policy. This is a study by my colleague Henrik Österblom and a number of colleagues. What they did is that they created a database over all seafood companies in the world. All seafood companies in the world. And looked at the revenues of these companies. And what they discovered after some analysis is that the top 10% of these companies account for 38% of all revenues globally. Right? So there's a top 10% of these companies that have a huge benefit of these global commons that we call fisheries. So that's interesting. What they also discovered is that what they call keystone actors are actors that have a large influence in the system, that 13, by picking just 13 of these companies and their subsidiaries, they control up to 40% of the world's fisheries. So we're talking about 13 companies that are modifying global fisheries at that scale. That's not a lot of actors transforming the planet. And you can look at this and say, wow, that's a massive concentration of power, massive concentration of resource extraction, because they dominate global production. They control very important segments of seafood production. They connect ecosystems globally, and they influence global governance processes and institutions. The thing is that once you have the name of those 13 companies, you can actually invite them to a dialogue and talk with them about needed changes in the way they operate in fisheries that would have global impacts. And this is happening now, actually. So we've started such a dialogue with the CEOs of these 13 companies to talk about their influence and the way they can change. Maybe it's naive, right? Maybe none of them will change, or maybe a few ones will change. But if they change, that would have a transformative impact. So I believe if you think about transformation, it's both the bottom-up things, the shadow networks, the policies to upscales and side scales and deep scale, and the individuals pushing this, but also actually strategically targeting these key actors that have an unproportionately large impact on a system. Because if you get them to change, you will see things happening. So I'm just going to wrap up a little here. The way I think about global sustainability, and this is probably a different framing from what other people have, but I think this is one important one, is to think about the long history of Earth and think about this last 10,000 years of unusually stable climate conditions. And it was only in that phase of the history of planet Earth that human civilization could grow and that we as a species could flourish. We need to keep that in mind. So it matters. This stability matters, and we need to be aware of that. There's a current discussion in the climate sciences and earth system sciences about trying to identify the most vulnerable points on planet Earth that keeps that stability. And some people call it tipping elements, some call it switch and choke points in the Earth system, etc. This is just a an example of these sort of global tipping points. And there are current discussions on that you need to create early warning systems to keep track of changes in these points, right? We need early warning systems so we can respond. And I think that's good. I think it's important. But we also need to think about global tipping points for positive biosphere-based innovation. So we can pick up the really good ideas and scale them up quickly if they prove to be good, or test them and scale them up. We can't forget to test them. And this is a project that my colleagues have started. They call it Seeds of a Good Anthropocene, where they're trying to collect these examples of transformative biosphere-based innovation and change to get an overview. So you can go into the database, you can look at these different seeds. The neat thing about this is that it's nice for storytelling if you want to show people like these are good things happening in the world. But underneath it, the ambition is to start doing solid scientific analysis of these cases once you get up to a number. So I would recommend you to check that out if you want to. And in general, I mean, if you want to, just to summarize the 4 key points, what is global sustainability? In what sense is the 2030 agenda important? What can we do about it? And how do we work with this based on principles from resilient science? I would say the first point is that to really acknowledge that the biosphere is the basis for human prosperity for all. It's the basis for that, for all SDGs. If you can't secure that basis, you will not reach any of the other goals in the long term. And another thing that we need to, I believe, start to think about is to complement current thinking and current technologies and policies that focus on minimizing environmental impacts to innovations and policies that creates innovation that build intentionally the resilience of the Earth system. Biosphere positive innovation that I mentioned. If you're able to do that, then you will change the narrative a bit from a discussion on planetary risks to planetary opportunities. And I think that would be a very important leap forward when designing and communicating with the public. So I just want to thank you all for your patience, and I want to reciprocate this invitation to beautiful Barcelona to invite you to beautiful Stockholm in 2017 for the big Resilience 2017 conference, where we will present and discuss the latest progress in our science, but that also will include some policy dialogues as well. So you're warmly welcome. That's the site. Thank you.